I am Kevin Goldsmith. I am the Chief Technology Officer at Anaconda. And I am really happy to be here. I was really excited about this conference 2 years ago when the original plan was to host it, just because I love this idea of mixing, talking about agile, but specifically from an architectural framework. That's such a great idea for a conference. And sorry, I'm just realizing that I'm going to have to switch this to a different USB port. Okay. Today I'm talking about architecture and organization. And of course, I'm talking about it. And when I talk about it, I got to talk about Conway's Law. You can't talk about architecture and organization without talking about Conway's Law. And I normally, when I give this talk, I then ask, like, how many of you have heard of Conway's Law? Except, given this conference, you've all heard of it about 15 times yesterday and today. It's come up in nearly every talk I watched. So you've all heard of it now, and you've probably seen the quote. I'm going to go deeper into it than you might have heard about before, give some more context around it, and then actually talk about how this has affected organizations I've been in and the software architectures that we built, and actually how to take advantage of some of that. The one thing that we don't talk about, or I didn't hear anybody mention, Conway's Law is 54 years old. This isn't like from a few weeks ago that somebody tweeted this. This is actually, beginning of our industry. This has been around for a long time. And in fact, Conway, of course, didn't call it Conway's Law. Not Mel Brooks, but Fred Brooks in the book, The Mythical Man Month, another classic of in the literature of our industry, is the one who coined the term Conway's Law. But 1968. The cool thing, by the way, Mel Conway's still alive. In fact, he is on Twitter. Mel Conway's still alive. He has a website. You can download the original article from his website, a PDF. It is 4 pages long. So if you actually haven't read the original article, you should, because it takes about 10 minutes. And it gives you a bit of a different perspective than this quote. This is being Conway's Law. All right, so I'll just, organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. This is Conway's Law. It's a little wordy, right? The simpler version of this is any piece of software reflects the organizational structure of the that produced it, right? There's an equivalence there, kind of a mapping. I like this version of Conway's Law from Eric Raymond. If you have 4 groups working on a compiler, you'll get a 4-pass compiler. Or this one from Tom Cheatham, which is if you have, and this shows its age a little bit, if you have a group of n persons implementing a COBOL compiler, there will be n-1 passes because somebody has to be the manager. And for the last couple decades, that's been me. So, I like that I get to be present in this as well. What it also means is that when I see an architecture that looks like this kind of layer cake architecture diagram, I'm pretty sure I'm going to see an organization that looks pretty much like this. And the reason I say that is because I've talked to lots and lots of companies. I've worked at a bunch of companies, talked to lots of companies. I see this over and over and over and over again, right? It is a pattern that everybody does. Why? Because it makes a lot of sense, right? Especially when you talk about like connected applications like you do today, where you might have a website and mobile apps talking to a backend. Okay, well, you have one team per platform. Then you have some business logic that unifies all those teams so they do implement the business logic in a consistent way. And that's the core library. Now you might call that platform. That runs on top of, that talks to servers, that lives on infrastructure, right? And then you need one team for each of those. And then you have maybe a manager across the horizontal. I just see this over and over and over again. So Conway's Law, very much over and over and over again. And you can say, well, that's great, but when Mel Conway wrote this in 1968, like they wrote software really differently than we do now. Like we write software completely differently. And in fact, if you read that quote, he's talking about architecture organizations. He was an architect in an architecture organization. They didn't produce the software, they produced the software designs. And then another team in another floor, probably another building, possibly a different campus, was actually then taking those architectures. He wasn't even thinking about how we implement, how that software got implemented. So why do we still talk about it? Like he was working a completely different thing, completely waterfall. We don't do that anymore. This separate architectural organization, we don't do that anymore. But we still talk about Conway's law, like, as I said, like 15 times yesterday, probably 10 more times after I talk about it today. Why do we keep talking about it? The reason I think is something he calls the homomorphic force. So again, from the original article, speaking as a mathematician might, we would say that there is a homomorphism from the linear graph of a system to the linear graph of its design organization. Again, he's talking about architectural organizations, not talking about implementation. So homomorphism, if you go to the actual mathematical definition, it's a structure-preserving map between two different algebraic structures, right? So there's a map from the graph of your architecture, that layer cake, to the graph of the organization. That just happens. It happens a lot. And I used to work with somebody named Britt Andreatta. Britt Andreatta is kind of an organizational type coach, but who also studied neuroscience. And I was talking to her about Conway's law and how I'd seen this a bunch of times. And she mentioned something I'd never heard about. She said, oh, well, you're talking about maps. Well, you know, there's a part of your brain that stores maps. It's called the entorhinal complex. It's right by your brainstem. The entorhinal complex stores the map of how you know how you'll get from here to the coffee, right? Your physical maps, or how you'll get from here to your home at the end of the day. It also stores like virtual maps, the map of your organization, your social graphs. It also stores the graph of your architecture. That's what your entorhinal complex does. It likes to save itself some energy, right? It likes to save itself some work. It likes to find these equivalences. And the way you can sort of kind of visualize that is an example like this. And this is an example from my life. You probably had this as well. A company I worked in a few years ago, we were on 7 floors of a building. And I worked on one of those floors. 6 of those floors were identical because we remodeled them. One of those floors was different. And it was because we'd taken it over from another company and they just remodeled it. So we didn't want to do that again. So we just replaced the carpet, repainted it, put our furniture in it. But it was just slightly off. Every time I went to that floor and I wanted to get a coffee, I would walk into somebody's office. Because on every other floor, that's where the kitchen was. On this floor, it wasn't. Even after I worked there for years, because I would be there on that floor once every couple of weeks, and I kept doing this. And it was just because my entorhinal complex said, this kind of looks like these other things, this is where that is. It's when when you go to a tall building, you know, oh, if I need to get the elevator, it's in the middle of the building. Because that's where it is in every other building. It just makes sense. That's your entorhinal complex telling you that. So it wants to find these equivalences. It helps it understand things. If you were in an organization, you were saying, you joined a new company, you said, oh, I found a bug in the Android app. Who do I talk to? And somebody said, oh, you talk to the server team. They're the ones who are responsible for Android bugs. You say, wait, they're called the server team? Oh yeah, no, it's the server team. They manage this part of the layer cake. But there is another team that manages the Android client. Oh yeah. But they don't do the Android bugs. No, it's a server team. You say, how am I supposed to understand this? How am I supposed to remember this? This doesn't map. That map, you're breaking this homomorphic force. Now, another interesting thing about Conway's original article, he submitted it like to academic journals and to business journals because he thought it was an important thing he discovered. They all said no. No, this is not this is not an academic quality paper. This isn't true or whatever. He hadn't proved his hypothesis. However, we still talk about Conway's law, and we have for decades. So eventually, Harvard being one of the places he submitted it, Harvard Business School went back, and they said, you know what? This Conway's law thing is real. We should actually prove it. And so a group from Harvard Business School in 2007 did a big study. They published it in 2008. And they didn't call it Conway's law. They talk about the mirroring hypothesis. So that's their version of the homomorphic force, what he called the homomorphic force. And they had a different reason for it, which was their belief was that this communication structure, what Conway talks about as communication, they talk about as governance structures, problem-solving routines, and communication patterns. And what they were saying is, because of the team you're in, like you're talking to the people in the team you're in, and you have your way of building things, and the team next to you If they work with you, maybe you have some shared things, but then the team over here is part of a different group and they do things just slightly differently. And what that means is when you look to solve problems, you're going to look to solve problems in a way that's consistent with what your team does, but you don't talk as much to the team next door. And so it's going to differ over time, and that in larger scale is represented in your architecture. A really quick kind of mental exercise around how that happens. And it's, again, it becomes really obvious when you think about it. So today, you're learning a bunch of stuff, you're being inspired, you maybe have a good idea for a new feature or a new product. And you go to work tomorrow and you say, hey, boss, I was at this great conference, Agile Meets Architecture, and I got a great idea for a new feature for a product. And your boss, can I try it? Can I work on it? And your boss says, yeah, sure, go ahead, try it out. Good to build a prototype. So you start working on it, you start building it, and it looks pretty good. It seems like this is maybe something we want to do more of. So can I keep on working it? Yes, keep on working on it. Okay, now it starts to get bigger. Now it's starting to get a little bit hard for you to do all of it. Maybe you're now having to do data model stuff and you haven't done data model stuff before. And you're like, hey, boss, can I get a little bit of help? It's looking really good, but I need a little help with this prototype. And your boss says, okay, sure, yeah, it is looking really good. Why don't we get you some help? So somebody else from your team joins. And let's say you are perfect in your communication and your onboarding. You get this other person, so they are 100% in lockstep. They understand everything perfectly, the exact same way you do. You are both coming at it from the exact same perspective. Awesome. One, you never can, but let's say you could. Like, you've done your documentation, you've done your onboarding. You are both working perfectly together. But now you're going to start working on different stuff, right? Because you're saying, well, I'm better on the front end. You could do the data model. We'll talk all the time. We'll share stuff. I'll review your PRs. We're just going to communicate constantly. But you work on this stuff. I'll work on this stuff. It makes it go faster. Okay, great. But now you're going to start stepping on each other's changes. They're making a change to the data model, breaks the front end. You say, well, this is becoming a problem. We keep breaking each other. Let's kind of separate the concerns a little bit. We'll put an interface between our two parts of this project. Maybe we'll talk to each other through an API. Well, that's great, but now you don't have to talk to each other quite as often because now you have this API. Everything goes through the API. And what's going to start to happen very naturally over time is they're focusing on their stuff, you're focusing on your stuff, and these will start to diverge. It's a very natural thing. This happens in teams. This happens in organizations all the time. Coming back to Conway. This is when you read the full paper, you get access to, you start to see some more nuance in this. One of the things that I think you would, if you read Mel Conway's, what he writes today, very thoughtful thinker about architecture or about software. Mel Conway in 1968, kind of a grumpy blogger, right? What he says in the whole article is a very different take. The quote is true, and we live with it today because it's so true. But if Mel Conway had Twitter in 1968, this would have been a long tweet thread, or a blog post with a really compelling title like "Committees Ruin Software," or Teams Ruin Software," or something like that. And it's for quotes like this. So he says, "It is a natural temptation of the initial designer, the one whose preliminary design concepts influence the organization of the design effort, to delegate tasks when the apparent complexity of the system approaches his limits of comprehension." What he's saying is, when this design starts to get too big, like the example I just said, when it gets too big to store in your own head, what do? You delegate parts of it, right? You get somebody else to take on parts of it. That's a very natural thing to do, of course. Now, this is the turning point in the course of the design. Either he struggles to reduce the system to comprehensibility and wins, or else he loses control of it. Wins and losses being an important word here. What he's saying is, either when the design gets too big to store in my head, because he's really talking about himself, when the design gets too big to store in my own head, the natural inclination is to delegate it and give parts of it to other people to do their design. If I had the time to simplify my architecture so I could keep it all in my own head, then I wouldn't have to delegate it and I would win. But if I have to delegate it, I'm going to lose. And that's because the subtext is other people are going to ruin my design. I built this beautiful architecture. It's starting to get too complicated. If I could get a little bit more time to simplify it, I can finish it and it'll be perfect. But if I have to give it to the loser in the cubicle next to me, they're going to ruin it. And I always have to do that. My boss always makes me do it because it's schedule or budget that forces me to. So essentially what he's saying is, a subtext of the whole article is, if my boss would give me more time to just do my architecture, it would be way better because I don't have to delegate it to the person next to me. You know a lot of developers like that over the years. I'm sure you've met. So all this about Conway's law, we call it a law. Is it a law? Are we actually trapped by Conway's law? Is it like the law of thermodynamics? And the answer is absolutely not. Of course not. It's a mental exercise, right? You absolutely can build an architecture that is completely disharmonious with your organizational structure. Of course you can. We are evolved thinking apes. We can do lots of great things like this. The answer is, but why? Why would you? The effort to work around Conway's law is way worse than just to go with it, to accept it, to use it. If you're familiar with the martial art Jiu-Jitsu, the entire point of Jiu-Jitsu is to use your opponent's force, to take advantage of their force, as opposed to just fighting it, right? If you can do the Conway Jiu-Jitsu, where you take advantage of this homomorphic force, this mirroring, then you can actually do better things because you're not kind of fighting your own brain and the brains of everyone else in your organization. I've had a bit of experience trying to do this Jiu-Jitsu at different companies. I'll talk a little bit about that, ground this in a little bit more practical things. So about 10 years ago, a little bit more than 10 years ago, I led a product organization at Adobe called Adobe Revel. This was my organization that I was responsible for. If this looks familiar, it's because our architecture looked like this. There was a very strong equivalence. And of course, at that time, I wasn't really thinking about Conway. I was thinking about, it was a connected photography product. So there was mobile apps and desktop app and web app. And yeah, we had to have that shared business logic. And all right, we had a monolith because we had a monolith because it was 2011. And it was a single team because if you have a single team, what do you build? You build a monolith because why wouldn't you build a monolith when you have one team? Because at Conway, there's a reason for it. And that server ran on infrastructure. And this was, for me, this was the first time I actually got to build a product that you would download from an app store. Up until this point in my career, every piece of software I ever worked on either shipped on a piece of hardware or shipped on a CD or DVD and would take 2 years. So I was at Adobe. Before this, I worked on the Creative Suite. We would take 18 to 24 months to release a new version of product. And we were building Agile, but we were building Agile to a schedule, right? This was my chance to really build Lean, and I'd read Lean Startup, and I've been doing Agile for a long time. This was my chance to get value to our customers as quickly as possible and to really live that OODA loop, and I was so excited to do it. I was like, we're going to ship as fast as we can, and back then, Apple wouldn't let you ship more than once a month, but I'm like, okay, we're going to ship once a month. That in itself was amazing. This structure, this organizational structure, which made a lot of sense, given this architecture, right? It made sense, like no one questioned it. This was the way you would do it. This seemed like, why wouldn't this do what we needed to do? But we kept having this problem. And the problem would be this. We decided, we want to add this new feature to the mobile app. Okay, so first sprint, one of the client teams or all the client teams said, hey, we're going to add this new filter to the photography product. Okay, cool. Oh, you know what? We need to synchronize that filter. Hey, core library team, hey, we need to synchronize this filter. Can you do that? And they're like, yeah, totally. We're going to do that next sprint. Awesome. Okay, then the core library team picks it up and they go, oh, you know what? We need to synchronize this on the server. Hey, server team, can you add an API so we can synchronize this? Totally. We'll do that next sprint. Awesome. Then, hey, you know what? We need a new database for this thing. Infrastructure team, can you stand up a new database? So yeah, totally. We'll do it next sprint. Awesome. Then it's like, hey, guess what? The database has stood up. Awesome. The API has stood up. Great. Hey, the core library is ready. Awesome. Yay. And what happens? We're now 7 sprints in. right? Or for us at that time, 14 weeks, like 3.5 months to do the simplest feature. And that was driving me insane. Because here I was so excited, like we're gonna bring value to customers, and I couldn't, and we can ship once a month, and it was taking us forever to get anything done. And of course there were ways around it. We switched to Kanban. There's lots of different ways we could have done it, and there's lots of things we tried to do to improve that velocity, but it was the organizational structure, which was tied to the architecture, was producing problems not based around the architecture. There was no architectural limit. It was an organizational problem that was slowing us down. And we did different things. And by the way, like the teams didn't like it either. So eventually what started to happen is the client team said, well, we know how to talk to servers. We don't need this library in the way. We'll just talk directly to them. And of course, the reason you have like a core library or platform is to make the stuff consistent. And so we started getting bugs because the Android client and the iOS client implemented the same business logic differently. Stuff like that started to happen. Eventually, what I told the teams was, start treating each other like your vendors, like your external vendors. Like if you work with an external vendor, like a database company or something, and you say, we need this feature, it's really important. The vendor will say, we love your business, we'll absolutely implement this feature. You'll get it in 6 to 12 months, because that's their timeline when they work with you. And you go, okay, great, that's awesome. So I started to say, and you don't wait for that vendor to deliver that feature, you just move on with your life. And I said, let's just start queuing stuff up, and we'll just try and maximize the throughput, and there'll be a lot of latency, but at least all the teams will go faster. So that was a step towards autonomous teams. I didn't realize that at the time, but I had a problem here around throughput. We tried to solve it with my understanding of what autonomous teams were without me really understanding that that's what I was doing. Somewhere in here, after kind of working through this and trying to figure this out with my teams at Adobe, I got a call from Sweden. And they said, hey, we're looking for a new tribe lead for the music player tribe. And this was 2012. So this was before Spotify. We knew Spotify, like we know, a lot of us know Spotify now around the organizational structure. So the white paper had been published, but nobody had read it yet, including me. So they sent me the white paper. This is how we're structuring our organization. And I went, oh my goodness. And by the way, I'm not going to talk about the Spotify squads tribes model because you've probably heard it before if you care about it. And I've given talks on it. There's plenty of places you can hear about it. So I'm not going to get too deep into it. But the cool thing was Spotify had started with the same problem that I had in Revel. This is the Spotify architecture, especially the original Spotify architecture, not really that dissimilar from what we were doing in Revel. And because a client app talking to a server to download music or stream music and upload playlists, which are synced across all your clients, not that dissimilar from a photography product uploading photos that are then synced across multiple clients. They started with the same architecture because it makes sense, it's obvious. And they originally had the same problems I was having in Revel. The difference was they were way smarter than I was and saw this problem earlier. They were scaling faster, the team, than I was. And so they actually thought through this a lot more. And what they realized was, just as I had, that this structure, which comes from the architecture, the team structure that is obvious given the architecture you're building, was the problem. And that also meant, because they understood Conway's law, that you both needed to change. And so that was where the Spotify squad, which is a feature team, which is a full stack team, came from. That was partially to address this velocity problem that I was also seeing at Adobe. They solved it in a different way than I did. And if you're unfamiliar with the Spotify model, these feature teams contain server developers, testers, mobile developers, web developers, essentially everything you need to be a fully autonomous team, have no dependencies on any other team. Of course, there are a little bit of dependencies. There's a very light dependency on infrastructure, but if you think in terms of like what we talk about with Dora and stuff like that now, Spotify had figured that out. The infrastructure team was really about developer enablement and self-service so that there would be no dependencies. Similarly, on the client side, they just would pick up and kind of assemble all the features from all the feature teams and just deliver it to the App Store. They had there was very little synchronization that happened there. Everything was about reducing synchronization between teams to improve throughput on a per feature basis. And it worked incredibly well. I worked there for 3 years. It worked very, very well. But of course, you couldn't have this same layer cake. They really had to break the layer cake apart and really build these kind of silos of features. And similarly, while they had started with, a long time ago, with a Python monolith, because when they were 6 developers in somebody's apartment in Stockholm, they built a monolith, because that's what you do. That wasn't going to work anymore when I was there, 800 developers, or by the time I left, that didn't work anymore. So if you looked into their layers, that infrastructure and server layer, it kind of looked a lot more like Swiss cheese, because what it was dozens and dozens and hundreds later services. When I left, there were 800 developers, so I left in 2016. There were 800 developers, there were 800 services in production, which is a lot, given that most of the developers were not back-end developers. They were front-end developers or mobile developers or testers or whatever. So some of the squads in my tribe would have 3 or 4 back-end developers, some of the bigger ones, but they would be responsible for about 20 services. But that worked perfectly because they could implement their services without dependencies on other teams and move forward. They changed the architecture to match the organizational change so that they could go faster. That's what they did. They used Conway's law for good. After Spotify, I went to go work at this company called Avvo. And Avvo, probably if you join a new company, you've seen this. I'd just come from Spotify, so I had all these ideas, and I'd been kind of scaling at Spotify for a few years. Avvo had started down this path, right? It was a startup. It was about 10 years in. They kind of started down this feature team path inspired by Spotify and kind of only made it partway down the path. They were midway through their transformation and kind of had given up. So some decomposition of the monolith, some feature teams, but a lot of stuff was still in the monolith, and they needed help. And they were struggling to get stuff done. So, okay, we did the obvious thing. I didn't want to just redo Spotify, because why would you, right? In a different company, I wanted to do something that made sense. But because it started down this feature team path, we went down this feature team path, and that helped. But we were not scaling like Spotify was. So it didn't make sense to kind of take that through its logical conclusion. But also we were dealing with different problems than Spotify was. We were following much more of a jobs to be done kind of approach, which meant that given our product, which was a legal marketplace, or is a legal marketplace, we ended up with something kind of like this, where we ended up with a lot more shared code between teams. Everything lived in a team, but where we did this. And that architecture made sense for the product architecture. But then we had to reflect that in our software architecture as well. So those kind of layers were completely gone. We had bags of features owned by these kind of bigger teams that were each focused on a user journey. But we had to make sure the architecture was cognizant with the organizational structure. And for us, we were organizing it not around feature level velocity and throughput, but around kind of solving jobs to be done. So we were working with the homomorphic force. We were working with Conway's law in the way we designed that organization and the architecture that we evolved. How do you do this? How do you do this when you go back? The sad part is there's no like, oh, okay, you do A, B, C, and D, and then you're done, and everything's great. Because it doesn't quite work that way. Of course, nothing does in Agile. It depends. But also, like a lot of things in Agile, the best way to use that homomorphic force to do that Jiu-Jitsu is to be deliberate. Make choices. Don't slide into things. Don't let things evolve organically without understanding things. So for example, if you know, which you hopefully do now, if you didn't before, that there is going to be architectural implications to your organizational design, make sure you're making choices with that understanding. If you make a change in your organization, it's going to change your software architecture. It just is, because you change who people talk to. They talk to different people than they did before. They stop talking to people they used to talk to all the time. They're going to start solving problems with the context they have, and that's going to be different than it was before, and your architecture will change. So make that understanding. When we change the architecture, like let's say we want to update the architecture, make an architectural change, and you know that it isn't reflected in some way in the communication patterns in your organization, that change is going to struggle. It's going to be hard to make happen. And conversely, if you make an organizational change without understanding the architectural change it will produce, then you can't be surprised when your architecture changes or you struggle with stuff that used to be easier before you made the organizational change. Find the communication patterns in your organization that conflict with your software architecture or your desired software architecture, and either enhance them, which is, we don't talk a lot about let's build silos, but it is actually something we need to do sometimes. Let's build silos so we can change our software architecture. We can evolve our software architecture differently. We talk about removing silos all the time. And there is a good value to that. There's a good value to having more context and more information, but to be aware of where those silos exist, create them sometimes is actually a good idea. And then just broadly, if you have an architecture you're trying to evolve, change your organization in a way that would map very cleanly to that new architecture. That, by the way, actually has a name, that tactic. That tactic is called the reverse Conway maneuver. It is one of my favorite kind of phrases in the industry. It's just fun. It sounds like a spy movie type thing. That would be a good spy movie title, the reverse Conway maneuver. If you've ever read Sam Newman's book called Building Microservices, which is another great book, he talks about this actually in terms of Netflix and Amazon. So what he says is Netflix learned from this Amazon example. So he's talking about how Netflix was inspired by Amazon and ensured that from the beginning it structured itself around small independent teams, what Amazon used to call the two pizza teams, so that their services they would create would also be independent from each other. Netflix had a goal, which is to create these independent services. Amazon had gone the very same route. Spotify was influenced by Netflix, absolutely. Spotify learned from Netflix, Netflix learned from Amazon, Amazon learned from somebody else, I don't remember who. Amazon didn't invent it, but they knew it. This ensured that the architecture of the systems were optimized for the speed of change, very much like Spotify wanted to move faster, Netflix wanted to move faster, Amazon wanted to move faster by reducing dependencies between teams. And the best way to do that is to create services that were independent of each other. Effectively, Netflix designed the organizational structure for the system architecture it wanted. That is the reverse Conway maneuver. Okay. I'm going to come back to Harvard, because you know what? Harvard actually proved Conway's law. They called it, they talked about the mirroring hypothesis, and what their understanding was modular software was better than non-modular software. Okay, I think we can generally agree with that. And what they wanted to do is prove that organizations that were loosely coupled produces software that was loosely coupled. So they talked to thousands of organizations, big companies, small companies, open source projects, studied the organization, studied the software they produced, and they found an equivalence. They essentially proved Conway's law for the business school definition of proved. So you can now point at that and say, no, it's not. It is a law. It's a business school law, not a physics law, but it still counts. So to sum up, Conway's law. Whether you call it Conway's law, whether you call it the homomorphic force, whether you call it mirroring, it's going to happen. It's absolutely going to happen, and it's going to happen because your brain kind of wants it to happen. You have to fight your own brain if you don't want it to happen. So go with it. Take advantage of it. Do your Conway Jiu-Jitsu. Thank you. So happy to take questions now. And you can ask the Spotify questions if you want.
Yeah. So thanks a lot for this talk.
Thank you.
And yes, we got quite a few questions already,
excellent.
but we might have some more on the audience. If you have some more, then please raise your hand so I can come to you with a microphone. But let's start with the Slido questions. One I liked quite a lot. How do you guarantee consistency, in brackets, product quality with independent feature teams? And the person was just looking at the quite buggy and inconsistent Spotify app at this very moment.
Sure. Okay, so the Spotify app today, and I'm still a daily user of Spotify, is way better than it was when I joined. When I joined, you could, Steven Sinofsky says, don't ship your architecture, or don't ship your organization. What he means is like, he's talking about Conway's law. He's saying, oh, don't do that. You guess what, you're doing it anyway. He says, Microsoft, we didn't do it. Yeah, I worked at Microsoft for 9 years or 8 years. We totally did it. But it was way worse. Like buttons in different parts of the main window worked differently because different teams worked on them and never spoke to each other. One of the things that Spotify did to try and unify some of the stuff is they had the designers kind of sit together one day a week, and then the other 4 days of the week they were with their squad, so they would share stuff. Eventually, there was actually, when I was there, they started the team that kind of built the kind of common sets of controls. But quality and different things working different was always a challenge, because when teams don't talk to each other, yeah, they tend to, that's building silos. Spotify built silos for architectural gain, right, for architectural design. And so what you had to do was people like me, like the tribe leads or the more senior leaders would have to go and look at stuff and then point stuff out to different teams, because oftentimes they weren't really looking at each other. Obviously, with a product like Spotify, everybody was using it all day, so they kind of knew, they would see it themselves often, but no, that is a challenge. The way you do it is by actually having people look across stuff from time to time. But it'll happen, it's just part of it.
Great. So questions still popping in, and we're probably not being able to answer all of them, but I go with another one.
This is my Twitter.
Yeah.
If you give me the questions, I'll try and answer any questions I don't answer here on Twitter.
Another one. How would you sell the idea of Conway's Law, I guess, to managers who do not have any understanding of software development?
I would send them the Harvard Business School paper, actually. No, I mean, I actually would. Like, we managers like our Harvard Business Review. And you can say, no, Harvard says this is a thing. And it also, they do a good job kind of, they're talking about software, but they're trying to talk more generally, not just about software stuff. So it's a good actual, if you read that article, which is also not very long, it's a nice kind of introduction into this idea that isn't so tied up into software.
Cool. Then another one, what are your tips or ideas on when to use model or library sharing between teams?
So it depends for me a lot on the size of your organization and how fast you're scaling, to be honest. So at Spotify, we didn't at all by design. And that was on purpose, which meant that each of those squads were pretty big. And we had a lot of people doing the same jobs in different teams, and we ended up with a lot of duplication of effort, and that was okay. That was considered okay because the main goal was throughput and velocity, and we were very happy to sacrifice kind of financial efficiency in order to gain that. Since then, I've worked more at Series B, C, D type startups where we don't have that luxury of being able to hire zillions of people, and we have to be much more efficient. And so for that, we do share more code. We are doing that a little bit more. But what I tend to like as a pattern, and what I've adopted a lot since Spotify, is usually a single team needs something, so they build it, right? And that's cool. And if another team needs something, it's around the same time they can build it too, but usually one team builds it, and then another team says, oh, we need something like that. Okay, and then maybe they'll modify, they'll put PRs on that code, but one team's still responsible for it. And eventually, when the third team starts on it, that moves into the platform team. And then the platform team takes it over at that point. Because now enough teams are using it that it makes it more sense for it to be centrally managed. And so that's how I've been doing it ever since. And that's a much more efficient way to do it, so we don't have a ton of duplication of effort. But we don't have everybody kind of locked in waiting for the platform team to build something for them that services everybody. Instead, each team solves their own problems. If the way they solve it helps another team, then eventually it moves to platform.
Okay. And a last one, maybe a little bit along those lines. How do you handle maintenance and operations when feature teams are reteaming dynamically?
So I have a longer version of this talk where I talk a little bit specifically about that, because one of the things my tribe at Spotify, because we were building the apps and the desktop app and stuff, our teams weren't that dynamic. Search is always search. Like that team, people were on that team for years. So it wasn't like we were blowing up teams, but other parts of the organization, like the infrastructure team, they were constantly blowing up teams and building new teams. And I was really jealous of that kind of constant reteaming. And so at Avvo, I didn't talk about this, but our teams, because we couldn't build like Spotify level tribes, we weren't scaling that fast. So we had kind of medium-sized teams. And within those teams, they were reteaming. In those groups, they were constantly reteaming, but those groups were more consistent. So we were about 20 to 30 people. And so that way we got some of the benefits of this constant reteaming without some of the losses where knowledge gets spread out too thin, or you lose teams feeling responsible for things. I don't know if that was the original answer to the question.
Yes, somehow.
Okay, close enough.
That's fine. Thanks a lot very much for the talk. Questions will be open still. So
yeah,
thank you very much.
I'll try and answer on Twitter anything I didn't answer, or I can talk to you after this. Thank you.